All right, let's work more on simplifying some square roots and cube roots that contain some algebra expressions. So if you look, the first thing I always do when I'm dealing with square roots and cube roots is I write my perfect square and perfect cube list on my paper so I have it in front of me to look at. It helps a lot. All right, I want to simplify the square root of 18, a to the 7th, b squared. I want you to notice this is a monomial. It's all connected by multiplication. So technically speaking, we could break this up. I'm asking you to do the square root of 18, the square root of a to the 7th, and the square root of b squared. Well, the first thing we got to know is, are we dealing with perfect squares? So let's deal with our coefficient 18. Is 18 a perfect square? No. If I look at my list, 18 would be right here. It is not a perfect square. So what I need now is the biggest perfect square that divides into, that's a factor of 18. And if we look at our list, the biggest perfect square for 18 is 9. So I will rewrite this as 9 times 2, which is equivalent. I can square root 9. What is the square root of 9, ladies and gentlemen? That is 3. That's why the 3 comes out as a whole number. We did the operation. Can we square root 2? No. 2 is still not perfect square, and 2 is prime. It's in lowest terms, so the 2 has to stay inside the radical, because we cannot do the operation. But we're not done. That just took care of the coefficient. Now we got to deal with the variables. So now I want to square root a to the 7th. Is a to the 7th a perfect square? No, it is not. For a variable to be a perfect square, it must have an even exponent. So, two ways to think about this. Either A, you can factor this. What would multiply to a to the 7th that would be the biggest perfect square? Well, with variables, we're looking for an even exponent. What's the biggest even number in 7? That's right, it's 6. So we can rewrite this as a to the 6th times a. Now we can square root. What is the square root of a to the 6th? Well, that's a cubed. A cubed times a cubed would be a to the 6th. Can we square root the letter a? No, that is understood to have an exponent of 1. And it's in lowest terms, so he's got to stay inside. Another way to do this mentally is to think. Square rooting means to take this exponent 7 and divide it by 2. 7 divided by 2 would be 3. That's why there's an exponent 3 on the outside. With a remainder of 1, there's an exponent of 1 on the inside. But we're not done. We still got to square root b squared. So is b squared a perfect square? Yay, it is. It's got an even exponent. What's the square root of b squared then? That's just good old b. Now, if you think you're leaving the final expression like that, you're crazy. Everything here is connected by what operation? Multiplication. So let's multiply. What's on the outside of the radical? Let's multiply. We have 3 times a cubed times b. And we would write that as 3a cubed b. What's on the inside of the radical will multiply. So inside the square root, we got 2 times a, which is 2a. And there's our expression completely simplified. Okay, let's try cube root. I have cube root of negative 8xy cubed z to the 5th. Again, because this is all connected by multiplication, I can break this up. I'm asking you to do cube root negative 8. I'm asking you to cube root x. I'm asking you to cube root y cubed. And I'm asking you to cube root z to the 5th. All right, let's start with our coefficient, our number. What is the cube root of negative 8? Well, is negative 8 a perfect cube? Sure it is. 8's on the list. The cube root of a negative number would be negative, so this would be negative 2. Can we cube root the letter x? Well, to cube root a letter to be a perfect cube, you need a multiple of 3 as your exponent. Well, what's your exponent here? It's 1. 1 is not on the 3 times tables. The 3 times tables are 3, 6, 9, 12. So we cannot cube root x, so it stays inside the radical symbol. Can we cube root y cubed? Well, yeah, our exponent's at 3. That is a multiple of 3. So 3 divided by 3 is y to the 1st, or y. Can we cube root z to the 5th? No. 5 is not a multiple of 3. 3, 6, 9, 12. So we're going to have to break this down. 2 ways. What is the biggest multiple of 3 in 5? Well, can we rewrite this as z cubed times z squared? Because 3 is the biggest multiple of 3. We know the cube root of z cubed is just z. Can we cube root z squared? No. Cube root means we need a group of 3. Z squared is only a group of 2. So we'd have to leave that z squared in the symbol. Another way to think about it is to do the division. 5 divided by 3 would be 1. There's the exponent of the 1 on the z on the outside, with a remainder of 2. There's the exponent of 2 on the inside. Finally, because all these terms are connected by multiplication, you have to put it together. What's on the outside we multiply? Negative 2yz, and then we'll put in the cube root symbol, what we have left, x z squared. And that is how you simplify a radical expression.